Hi everyone, welcome back to Jamie's Hack Shack. Today we're on day 7 of the Pie Hut Maker Advent Calendar. Alright,
What do you have in here?
looks like we have... Is this an analog?
It's looks like a potentiometer.
Potentiometer.
Yeah, it's a slide one instead of a twisty one.
That's analog.
Yeah, but it's well, a twisty one could still be analog.
Yeah. So I was thinking of a light switch.
Yeah.
Make a switch.
So you got some jumpers here. You got a slide, and you got a little cap with a button on it. All right, and that's just a big variable resistor.
What's that?
Just something that's almost like a faucet, right? Like you can let a little bit flow through or not, and in turn, that can make a voltage higher or lower. And I think you'll see when we move into our first project here, our first thing we're going to do, we're going to use that as an input, as an analog input to make a change on a digital output. So let's check out and see what our first activity is. So we left what we had on there. We didn't have to take anything off, right? So we're going to be using GPIO 28. This is one of the Pico's ADC pins, and that stands for analog to digital converter. GPIO 26, 27, and 28, which are physical pins 31, 32, and 34, are all ones that are available to use as analog to digital converters on the Pi Pico. So essentially what we're going to be doing is supplying some voltage in to this variable resistor or potentiometer, and then the value that comes out is going to vary between like 0 and the highest possible voltage that it could be. And based on that variance, I think we'll be doing some making some changes to our output, and we'll verify that in just a second.
Is it right?
Got that right?
Yeah.
All right, you got your ground to the ground?
Yeah.
Okay. All right, so let's plug it in.
This holiday season, PCBWay is spreading the cheer with awesome Christmas coupons. Visit their Christmas 2024 activity page to grab your coupons and save big. And keep an eye on their Twitter for surprise promo codes during the event. Hurry, the Christmas event runs until December 31st. Don't miss out on these festive savings. It's the perfect time to bring your ideas to life with PCBWay.
Okay, so in our first code we got here, we're going to import ADC, which is
Analog to digital converter. Yep.
And then to the pin, right?
Yep.
Then we're importing time like we've been doing these past few. And then we're going to set the potentiometer variable to the digital converter at this specific pin where the potentiometer is.
So based on you moving that, it should just print out every so often. The timer says the reading it's getting.
Yeah, and it's just going to keep on going because it's a wild truly.
All right, so
you ready to?
Yeah,
I guess we
go ahead and do that, and then we'll just see as you move this. Move it slow. See how that number's bigger now? If you pull it down, does it get lower, or is it?
And the max is 10,000.
Well, that's 10,000 ohms. I don't know if you'll see that reflected in the voltage.
Oh, okay. Sorry.
So how low does it go if you leave it? If you take it low and then don't touch it for a second, what does it settle on there? So you go from a low of 2 something, and it's going to float around a little bit. And if you go all the way up, what do you get? So that shows you what that does. And what's going to happen, I bet, maybe in our next example, you're going to piece out a range of those voltages, and that's going to let you do something else based on that, right? That's what you're doing.
Yeah, 6.5.
So that's maxed out, right? Yep.
So pretty much in this one, we're doing the same thing, setting up potentiometer, but this time we're also setting up the LEDs with where they are, and NeoPixel, which had that big library.
So we're just doing one LED, that looks like, right?
Yeah.
Okay.
And so we're setting up our colors, which is just kind of basic colors for whatever colors we want. Amber's is a little bit different than blue. And then we're going to set our reading value to 0. So we're going to use a while true loop. We're going to have this read the potentiometer value, and then we're going to print that, and then we're going to wait for a second, and then we're going to see if the reading is less than...
So it has given you like a range to deal with there?
Yeah.
So as we move through the range of this, if we don't go giant moves, if we go slowly, we should see it start out with one color, have another color in the middle, and then another color at the top, right?
Yeah, so this one's going to be less than 20,000.
Okay, so what are we starting at now?
We're starting at red.
Is that correct?
Yeah, we're just going to keep on moving up.
All right, what's it going to change to in the middle? When we get
Move
20,000.
20,000.
All right, are we going to cross there? Here we go. Did it change color?
Yeah, it's amber.
Okay, now keep going, and once we hit a 40, is that right?
Oh, we're not there yet.
Or after you pass 40?
40?
Did it change?
Yep.
All right. So that works as expected. So that's what you've seen. You've seen an analog thing
Oh,
affect a digital change, right?
yeah.
So that's pretty cool. Yeah, look at that.
All right. So in this code, this time we're doing the same thing. We're importing everything. We're setting up our potentiometer. We're setting up our LED. This time we're putting our analog reading at 0, and we're setting our GRB value to 0. We're using a while true loop. We're just having the analog reading be what the potentiometer is reading. But this time we're going to set the GRB value to, what we're going to do is we're going to take our analog range, which is
That's the max.
65,535. Then we're going to divide that by the GRB range, which is 255. And then we're going to multiply that by what the analog reading is, like on the potentiometer. And then we're going to round that because the GRB code is not one floats, or which is decimal.
Right, we're just getting it to a manageable number to make differences with from 0 to 255, as opposed to trying to go from 200 to 65,535.
Yeah. And then after that, we're going to print the values, which we're going to print out the original analog value, which is the original analog reading. And then we're going to print the GRB value. And then, yeah.
So the color's not going to change, if I understand this correctly. We're just going to be changing the brightness of it, right?
And, well, we're going to light the LED with the converted BRQ value.
But part of that is just the intensity, right? It's just we're only changing one field, right?
Yeah.
0, 0, and then the number. So whatever that color is.
That's blue.
So so this should be just fading a blue from nothing to as bright as it can go.
Yeah.
Something got goofed up. Okay, now it's off. Now as you raise it, look at that. Slowly gets brighter. And if you slide down, and look how and so you can see the two values there that is showing as it cycles through, right?
So this is max.
Yeah.
Then we'll get low. So we're just making it brighter.
So that works as expected. That's pretty cool. Yeah, man. Let's see what our next one is.
All right. So in this code, we're doing the same thing, except we're also importing random, which we used. I think that was the last one, or the one before that. And this time we're still setting up our LED, but this time we're setting a flash speed variable to 0. We're using our while true loop, which means it's just going to keep on going until we make it stop. And we're going to set the flash value to how the potentiometer reads, divided by 65,000. And then we're going to generate some random GRB values by using random, and then a random, because you do random and then random integer.
Yep.
0 through 255. And we're setting this to GR and B. And then we're going to fill that LED with GR or B. And then we're going to use write, send that over. And then we're going to set the time sleep, which is the little delay, to flash. So whatever the potentiometer reads, divided by 65,000.
So the colors will be random, but the speed of the blinking will be controlled by where our potentiometer is.
Yeah.
So I'm assuming if we start down here, it should be slow at first, right? So let's see if that works as expected. Whoa, that's really fast. Maybe it's the other way around. So you could think of it as you go up, you're adding delay instead of the other way around, I guess, right?
So let's see that.
So that's going to be whatever, super slow.
Yeah.
At this time, we're not printing out any kind of output to look at, but now, but you can tell is.
Probably could print it out works. You could probably say.
But then when it gets fast, though, it's probably just going to fill up the console super fast, right? That's fine. We don't need to do that. But yeah, so that's pretty cool. So as you bring it down, it gets a little faster. That's pretty cool. And then you get down here and you're just like going pretty darn fast. Wow.
And I think that's it for today's video.
Wow, is it really? That went pretty quick. All right. What did we do today?
Video. We learned about potentiometers and analog signals versus digital signals.
Yep.
I think that's the difference. We created the circuit with that slide potentiometer, and we learned about ADC pins and how to use them in MicroPython. And then we used less, more than, equal to with if statements, which we hadn't done before with the little, like, your crocodile signs, or I remember like it's in each year's,
Yep.
We used number ranges. We learned about the round function. And then we used a random function that generates some colors and fill those in.
Yep. So I guess that's it for today. We will see you on the next day, and happy holidays, and we'll see you for day 8.
Bye.
Bye.